Hey everybody, Mr. Judson here. So this problem that we just did in our entry task where we were talking about, what happens to this fraction as x gets really close to some number is a pretty important concept in calculus. It's called a limit. And when we say a limit, what we're saying is, what values does an expression get close to as x gets really close to some number, right? So what values does an expression get close to as x gets, I'm going to say very close to a specific number. Actually, I'm going to add a little bit to this. I'm going to say, as we get really close to a specific number from both sides. So, if you think about as x gets close to 0, you're coming at it from the negative side, but you can also come at it from the positive side. And I want to know, what do these y values, if I've got a graph like this, what are the y values getting close to? Or maybe it's a graph that does something like this. It's got some curves in it. But as x gets close to a certain number, the y values approach the same thing. And we want to make sure that we always check this out from both sides. And I'm underlining that because a lot of times people forget to check from both sides. We just check from one direction, and then maybe we get an answer that's not necessarily true. We've got to make sure we check from both sides. Okay? So how do we write a limit? Here's the problem we just did. The limit, and you should probably just watch how I write this and how I say it. The limit as x approaches 0 of x cubed minus 1 over x minus 1. Okay, now I asked the question a little bit different on our entry task. I said, what do these values get close to of this function as x gets really close to 0? But this is the way we would write it in calculus. And again, we say that, the way we pronounce this is we say the limit as x approaches 0 of this expression, x cubed minus 1 over x minus 1. And so we're going to talk about 3 different ways to do limits. There's so I guess I'll just write methods. There's a numeric method. We'll say numerical method. There's a graphical method. And then there's an algebraic method. And the one that we really want to work towards is the algebraic method. Okay? These take too long. We're going to start with this today, but eventually our goal is to be able to do this algebraically. So a numeric method means that what I'm going to do is I'm going to make an x, y table. Our book, for some reason, likes to do these tables sideways. Okay, but this makes more sense to me. And I want to plug in some numbers really close to 0. I got the wrong number here. This should be as x approaches 1. Okay, so at 1, I am undefined. think that's what our entry task said. All right, so I want to plug in numbers really close to 1. I know that 0.9 is pretty close. 0.99 is even closer. And 0.999 is even closer to 1. That's from the smaller side. Okay? When I said I'm coming at it from the negative direction, it doesn't mean you have to have negative values. You know, I'd come along, hit negative numbers, I'd eventually hit x equals 0, x equals 0.5, 0.8, 0.9, 0.999, and I'm getting closer and closer to 1 without actually getting there. On the other side of 1, I could have 1.001 or just 1.1. And so what I want to do is I want to plug those numbers back into this function and see what I get. So I'm going to take my graphing calculator and I'm going to turn it on first, hit escape. All right, in parentheses, I'm going to plug this number in first, 0.9. So 0.9, I'm going to cube that and then subtract 1. Close parenthesis for the numerator, and then divided by, and I'll put the denominator in parentheses as well, 0.9 minus 1. And there's what I get, 2.71. Okay, then we'll plug in the next number. So now I'm plugging in 0.999, and so all I really have to do is go back and add a couple 9s in here. Go over here, add a couple 9s, hit enter, and now I have 2.997. So it looks like it's getting closer and closer to 3. I just want to make sure does the same thing happen from the other side. So I'll plug in 1.1. And hit enter. So I got 3.31. And now if I get a little closer, I'll plug in 1.001. So again, I just go back to my calculator. I just have to do a little bit of editing in the calculator. I'll put 2 zeros here and 2 zeros here. 3.003. So even though those aren't equal to each other, they appear to be getting closer and closer to the number 3. If I plugged in 0.999999999, a whole bunch of 9s, and 1.000000001, I'm going to get even closer to 3. So I'm saying that that right there is my limit. This limit is equal to 3. This is really important. I'm not saying that when you plug in a 1, you get 3, because you don't. You get undefined. What I'm saying is, as you get really close to 1 from both sides, your y values get really close to 3. Okay? It's important to understand, what we're saying when we do these problems. All right, let me get you guys one to try on your own. All right, so you guys go ahead and try this one. The limit as x approaches 0 of x over the square root of x plus 1 minus 1. So in our textbook, they want us to actually plug in 3 numbers that get closer and closer to 0 from the negative side, and then also 3 numbers that get closer and closer to 0 from the positive side. I don't really think you have to do that. I think we can just plug in 1 number and figure out what's happening here, okay? It takes time to plug all that stuff in, and it can be a little time consuming, but plugging in 1 number isn't too bad. So let's go back to the calculator here. I'm plugging in negative 0.001. So let me clear this off. I've got a negative 0.001 divided by in parentheses, I've got the square root of a negative 0.001 plus 1, end the square root, and then subtract 1, and then end the numerator. Okay, we hit enter, and I got 1.999. Kind of looks like my answer is going to be 2, right? But it's really important I check from both sides, okay? I don't want to get too lazy and just check from one because that's not always your answer, all right? Let's check from the other side. So really I just need to get rid of the negative sign. So I'll get rid of this. Get rid of that. I hit enter, and 2.000, I think it was 49, so we can call that a 5. It's not exactly 2, but you know, both of these again are getting close to 2, and so that's what I think our answer is for this. This limit is equal to 2. Now, if I want to check from a graphical point of view, all right, remember we have 3 methods here. What we're doing right now is a numerical method. We're plugging numbers in to see what we get. If I want to do a graphical method, it means I just graph this equation and see what it looks like on the calculator. So let me go ahead and do that. I think I've got it punched in here. Yep, there it is. So I'm going to graph it. And there's what the graph looks like. And so our question again is, what are the y values getting close to? So if I follow on the graph from both sides, getting closer and closer to where x equals 0, what I can see here is that my y values are zeroed in on that point. And I can even use the trace option as a way to verify that. If I plug in, if I trace to negative 0.001, see, there's my 1.999, and 0.001 from the positive side, there's that number. So in our book, when they ask you to fill in a chart and you've got to plug lots of numbers in, this is the quick way to do it, is to use the trace feature. Right? If I had to plug in a negative 0.01, negative 0.01, there's my y coordinate that I want to write down. Okay, so you can fill those charts in fairly quick using that trace option. All right, so there's my answer. I confirmed it graphically. I can move on to the next one. Let me get you guys another one to try. All right, the limit as x approaches 0 of the absolute value of x over x. On our TI-89, the absolute value command is the same thing as it is on the TI-84 ABS. And the place where you find that is if you just hit your catalog button. Catalog, come on, catalog, why isn't that working? Oh, because I can't use it when I'm tracing, that's why. So when you're at your home screen, if you just hit catalog, that ABS is the first option up there. Okay? All right, you guys go ahead and try this one. So again, I know I can't plug 0 in because we're undefined. That would give us a 0 in the denominator. So what happens right before that? What happens right after that? Well, I can just kind of look at this. You know, if I plug in a negative 0.001 into here, I take the absolute value, it'll make it positive, but then I divide it by a negative 0.001. Same number top and bottom. This one's positive, this one's negative. I get a negative 1. And if I plug this number in, absolute value of 0.001 is just 0.001. And then divided by 0.001, I get a positive 1. So anytime I plug in a negative number, I'm going to get that positive number divided by a negative, same number, which will always equal a negative 1. And if I plug in a positive number, absolute value of something positive is positive, divided by a positive number. That's positive, so I'll always get a positive 1. So the graph of this function looks like this. We're undefined at x equals 0. For all positive numbers, I'm going to get 1 for a y value. For all negative values, I'm going to get negative 1. Are those getting close to the same number? No, not close enough. You know, you'd look at that and you'd go, well, they are kind of close to 0. They're not too far off. They're not close enough. Look, this is always a positive 1. This is always a negative 1. What are my y values getting close to as I get closer? A positive 1, negative 1. Not the same. And so when that happens, what we say is that this limit does not exist. You have to be getting close to the same number in order for a limit to exist. An abbreviation for this, DNE, does not exist. Okay, you guys can go ahead and use that if you want. So this has no limit. Okay, let's try no. All right, the limit as x approaches 0 of 1 over x squared. You guys give it a shot. All right, so here's my numeric method. If x equals 0, again, 1 divided by 0, that's undefined. If I plug in a negative 0.001 and a positive 0.001, limits as x approaches 0 are pretty common, happens a lot. So using these two numbers is going to happen a lot. So on my calculator, I want to do 1. Let's see, turn it on. All right, so I'm going to do 1 divided by, in parentheses, a negative 0.001 squared. And I get a number like, what is that, 1,000,000? And then if I do the same thing with this, I'll just take the negative sign out. I get 1,000,000. So looks like it's getting pretty close to 1,000,000. What if I put another number in here closer to 0? Let's just double check and make sure. So all I did was add 2 more zeros, 0.00001. And so now my answer is, ooh, it got bigger. How many zeros is that? 10 zeros, I think. So 10 billion. I think if I add more zeros, this is going to get even larger. So really, I think this is getting close to infinity. Let's see what the graph looks like. So I'm going to go to my y equals, we'll clear this off. I'll do 1 divided by x squared, and then we'll graph that. Ah, yeah. I suppose, how do I know it doesn't go up and then connect and come back down? I'd have to look at this a little bit closer. But from a graphical point of view, it looks like this is what's happening. And that would agree with the number infinity. Now, I have seen some books that have said this limit does not exist. And the argument would be, well, why not? They're both going to infinity, right? Ah, but does infinity equal infinity? Ooh. That's why some people would say the limit does not exist, because I don't really know if infinity on this side is equal to infinity on this side. I'm pretty sure both of these graphs go up forever, and so I think the limit is infinity. But just to be aware of it, I have heard people say, no, that limit does not exist. But I think we are approaching the same y value from both sides. Now, if somebody asked me to prove that, all right, I don't know how to prove it. Nobody does, so got me, I guess. But I would answer this as infinity. Now, if we did a different graph or a different function, let's say I've got the limit as x goes to 0 of 1 over x. This is the rational function we talked about last year. And the graph for this looks like this. Okay, now I'm pretty sure that if I go to positive infinity on this side and negative infinity on this side, those are not equal to each other, right? So then I would say that this limit does not exist. All right, so that's what we got for today. Solving limits, new concept for us, but not a super hard one. I think we can kind of get this. And so what we want to do is we want to be able to either numerically or graphically find the answer. I don't really care which one you guys use. Sometimes our book will ask us to do it numerically. They'll give us a chart and ask us to fill it in. We should do it. Other times they won't tell us what to use, and I can use either one of those. The algebraic method, we're going to put that on hold for right now. Okay, we're going to work with this stuff first, but that's next in line. How would I solve these algebraically? Okay. All right, let's get ourselves an assignment. All right, so still assignment number 3. This is our 3rd week putting stuff together. Page 59, 5 to 8, 11, 13, 21, and 23. And so this stuff will be due on Tuesday for us next week. Okay. Don't forget I'm surgery on Friday. That shouldn't affect our class for tomorrow or for today, because this is videos for Thursday. But next week on Monday, I will not be in school. I'll be working from home, and I will have a video for you guys. No class, no Teams meeting, nothing like that. You'll just go ahead and take a look at the video and push forward from there. Okay? All right, you guys take care. I'll talk to you later.